Today I'm doing problem 21 on chapter 15. A cart attached to a spring with constant to 3.24 Newton per meter vibrates such that its position is given by the function x equals 5 centimeters times cosine 3.6 t radius per second. A during the first cycle for 0 to 1.75 seconds, at what value of t is the system of potential energy changing most rapidly into kinetic energy? B, what is the maximum rate of energy transformation? So for part A, we know the formula of the spring potential energy is 1/2 kx squared, where x is given by the problem, which is that 5 times cosine 3.6 t radius per second, and we know that the 5 centimeters is 0.05 meters, and then we can rewrite the formula. And then we can use our calculator to calculate the whole constant, which is 1/2 times 3.24 times 0.05 squared, which is equal to 0.00405. And just for writing purpose, I dropped all the units. So I take a derivative of the potential energy. And we have the negative, that which just comes from taking a derivative of the cosine squared 3.6t, which is cosine 3.6t times negative sine 3.6t. So I put the negative in front. And then to simplify this, we can find that the derivative of potential energy is equal to negative 0.01458 sine 2 times 3.6 t. The 2, so because cosine 3.6 t times sine 3.6 t is equal to sine 2 3.6 t, and then we take a second derivative for the potential energy, which we can find as negative 1.1458 times cosine 7.2 t, and then the chain rule times 7.2, and then we set it equal to 0 to find the maximum rate of change of potential energy. Then we drop all the constant. We can just divide all the constant, so we can put like cosine 7.2 t equals 0. And then we find all the t's using the calculator. But when we plug it back into the rate, we find that the 0.654 and 1.507 is the minimum, and then so the other two values is the maximum rate of change. So we can just, so the answer is 0.218 and 1.09. And then for B, we just plug it back into the rate of change to find the greatest. Whichever one, we can just plug it back in.